In question 12 we're given the following table here, and we're asked which row in this table shows what occurs in the eye as you watch a bird fly away from you. So as the bird gets more distant from your eye, what happens to the eye in order to adapt? So we have to figure out what happens to the ciliary muscles, the suspensory ligaments, and the lens. Now you should be familiar with all these elements of the eye's anatomy in order to answer the question. So let's quickly go through this. So when something's getting closer, and when something's going further away, so these two green dots here represent that, there are different morphological changes within the eye to adapt to that. So let's first think about what the determinant of this change in the capacity of the eye is. It's going to be the shape of the lens. The shape of the lens determines the shape of the light as it ultimately refracts through the lens and ultimately focuses on a point on the back of the eye, which is the retina. So the shape of the lens determines the angle of refraction. So we can see that when we have a fatter lens, when we have a more convex lens, as we would say, we have a much more refracted angle of the light, and therefore we can focus on something closer. However, when it's more long, i.e. less convex, there is a less sharp refractive angle. So what structures within the eye enable this change in the length, in the size and shape of the lens? Well, it's these two structures here. So we have here the ciliary muscles present within the walls of the eye, which contract and become more bulbous in the case of the more convex eye. When you want to see something getting closer, that's when the ciliary muscles contract to become fatter. The suspensory ligaments ultimately loosen up a bit, become a bit more wiggly, as we've represented here, as they're not under the same tension, and therefore you can have a more convex lens and see something closer. But we're interested in a bird flying away, therefore we need to look at the process for when something's going further away. So what will happen is that these same ciliary muscles will relax and become less prominent, and that will mean that there's more tension in our suspensory ligaments, so they'll tighten up, and that will enable the lens to become more convex. So this is what we're interested in, and this is what we need to corroborate with the table. So we can say the ciliary muscles relax, the lens becomes more convex, and the suspensory ligaments tighten. And having a look here, ciliary muscles relaxing, suspensory ligaments tightening, and lens becoming less convex corresponds to option B. So we can say our answer is going to be option B.